Good morning. Today we are talking about the atmosphere. The 5 different layers are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. First, we will look at the troposphere. The troposphere is the lowest layer of the Earth's atmosphere. The troposphere starts at the Earth's surface and goes up to the height of 7 to 20 kilometers above sea level. Almost all weather occurs within this layer. The air is warmest at the bottom of the troposphere near the ground level. Nearly all of the water vapor and dust particles in the atmosphere are in the troposphere. That is why most clouds are found in this lowest layer. In places where Earth's surface is bumpy, like where there are mountains and forests, the winds are all jumbled up. In smooth places like over water or ice, the winds are smoother. The troposphere is heated from below. The top of the troposphere is quite cold. The temperature there is around minus 55 degrees Celsius. Next is the stratosphere. The top of the stratosphere occurs at the altitude of 50 kilometers. The height of the bottom of the stratosphere varies with latitude and with the seasons. This is called the ozone layer. Ozone is an unusual type of oxygen molecule that is relatively abundant in the stratosphere. Heat this layer as it absorbs energy from incoming ultraviolet radiation from the sun. Temperatures rise as one moves upwards through the stratosphere. A commercial jet aircraft fly in the lower stratosphere to avoid the turbulence. The stratosphere is very dry. Air there contains little water vapor. Because of this, few clouds are found in this layer. Almost all clouds occur in the lower, more humid troposphere. Polar tropospheric clouds, PSCs, are the exception. PSCs are also called nacreous clouds. Next is the mesosphere. The mesosphere is 50 kilometers above Earth's surface and goes up to 85 kilometers. The top of the mesosphere is the coldest part of the Earth's atmosphere. It's about minus 90 degrees Celsius. The boundaries between layers in the atmosphere have special names. The mesopause is a boundary between the mesosphere and the thermosphere above it. The stratopause is a boundary between the mesosphere and the stratosphere below it. Most meteors from space burn up in this layer. A special type of cloud, called noctilucent clouds, sometimes forms in the mesosphere near to the north and south poles. These clouds are strange because they form much higher up than any other type of cloud. There are also odd types of lightning in this mesosphere. These types of lightning, called owls, appear dozens of miles above thunderclouds in the troposphere below. In the mesosphere and below, different kinds of gases are all mixed together in the air. Above the mesosphere, the air is so thin that atoms and molecules of gases hardly ever run into each other. The gases get separated, some depending on the kinds of elements, like nitrogen or oxygen, that are in them. Next, we have the thermosphere. It extends from about 90 kilometers to between 500 and 1,000 kilometers above our planet. Temperatures climb sharply in the lower thermosphere. They level off and hold fairly steady with increasing altitude above that height. Temperatures in the upper thermosphere can range from about 500 degrees Celsius to 2,000 degrees Celsius or higher. Although the thermosphere is considered part of the Earth's atmosphere, the air density is so low in this layer that most of the thermosphere is what we normally think of as outer space. The Space Shuttle and the International Space Station both orbit Earth with the thermosphere. Much of the X-rays and UV radiation from the sun is absorbed in the thermosphere. High-energy solar protons also tear electrons away from the gas particles in the thermosphere, creating electricity-charged ions of atoms and molecules. Finally, the aurora, the southern and northern lights, primarily occur in the thermosphere. Charged particles, electron protons, and other ions form space collide with atoms and molecules in the thermosphere at high latitudes, exciting them into high energy states. Those atoms and molecules shed this excess energy by emitting photons of light, which we see as colorful aurora displays. Lastly, we have the exosphere. The exosphere is the uppermost region of Earth's atmosphere as it gradually fades into the vacuum of space. The altitude of the lower boundaries of the exosphere varies. When the sun is active around the peak of the sunspot cycle, X-rays and ultraviolet radiation from the sun heat and puff up the thermosphere. raising the altitude of the thermopause to heights around 1,000 kilometers above Earth's surface. When the sun is less active during the low point of the sunspot cycle, solar radiation is less intense, and the thermopause recesses to within about 500 kilometers of Earth's surface. Since the exosphere gradually fades into outer space, there is no clear upper boundaries of this layer.